part of chapter 7 that we're going to talk about is motor development. So let's talk about some of the physical changes first. Now, motor development is going to focus not first, excuse me, on what are called gross motor skills. And gross motor skills involve the large muscles in your body. So think of, when you walk, run, hop, jump, pedaling a bike, balancing on one foot. These are where we're using the large muscles that help us move, locomotion. By age 4 to 5, most preschoolers have mastered large motor skills like standing on one foot, walking upstairs, running. Older kids are often able to coordinate multiple tasks like singing and running at the same time. Usually we learn this by watching other people and teaching ourselves just through trial and error. Girls and boys are similar in their motor skills, although there are a few advantages. Girls seem to show somewhat better balance and precision, while boys seem to be better at throwing and kicking. And actual individual differences are larger than gender differences. So it's not necessarily boys versus girls, but more person to person. Experiences in childhood and infancy can affect the development of motor skills. For example, kids who crawl earlier or have early crawling experience tend to perform better on the gross motor skills than do kids who didn't have early crawling experience. As far as physical activity goes, preschoolers spend about an average of 25 hours a week in large muscle activity. So again, running, jumping, climbing, balancing on one foot, those sorts of things. That motor activity then starts to decline after 2 or 3 years. 2 or 3 years of age, because they're able to sit longer and pay attention longer and have more focused attention. Now here are some examples of some gross motor skills that develop depending on your age. So you can compare 2 to 3 to 4 to 5. So if we look at 2 years, runs well in a straight line. 3 years, you can go around obstacles running. 4, you can turn sharp cut corners while running. And 5, you can run lightly on your toes. Not really being able to really ride like a bike or anything at 2. 3, we start to be able to get a little bit better at that. 4, we can ride that tricycle, and then 5, we can ride a big bicycle with training wheels. So you can see some of the differences in how that evolves. Looking at this page, we're going to talk about fine motor skills in a minute, so we'll come back to this. As far as gross motor skills, rough and tumble play and individual differences. Let's take a quick peek at that when it comes to gross motor skills. Now, rough and tumble play helps kids develop physical skills and social skills. We're talking about things like, running around, chasing each other, wrestling, laughing and making faces, hitting with an open hand. So just, good-intentioned, well-natured rough and tumble play. This is more common among boys than among girls. And we're not talking about aggressive behavior like hitting and pushing and grabbing, those sorts of things. Just rough and tumble. It does help then boys and girls develop not only physical but social skills. Now, as far as individual differences in physical activity goes, this is really interesting. They've done some studies, and physically active parents are likely to have physically active children. One statistic your book points out is research has shown that children of active fathers are 3.5 times as likely to be more active themselves than kids who don't have active fathers. So first, we're looking at sort of a nurture kind of thing here, where if you're seeing and you're being encouraged to participate in physical activity, then you yourself may be more physically active. But there also might be a genetic component. Twin studies have suggested that there might be a genetic tendency for activity level as well. Now, One of the other things that develops during this period are our fine motor skills. Now, fine motor skills are the small muscles in our hands and arms and feet, small muscles used to manipulate and coordinate. And we most often look at them in the hands. We think of things like drawing, cutting, using utensils. The development of drawing, as a matter of fact, is linked to development of motor and cognitive skills. Now, if we look, go back just a little bit, we can look at the development of fine motor skills in early childhood. If you see here, again, we do a comparison from age 2 to 3 to 4 to 5. So things like being able to build a tower of 6 cubes at 6, 9 cubes at 3, 10 or more cubes at 4 years. Build 3 steps from 6 blocks using a model by 5 years. As far as drawing kinds of things, at 2 years, copying vertical and horizontal lines. 3, copying circles, across, and letters. By 4, copying a square and simple words. By 5, copying a triangle, star, print your first name and your numbers. So you can see the development as far as that goes and things we're able to do. Now, if we come back here, if we look at some more specific research that's been done on drawing and how it's linked to motor and cognitive skills, we can look at some preliminary stuff done by Kellogg. And this was done very early on in the late 50s, early 60s, and 70s. Now, first we begin to scribble and draw just for the fun of it, just because we can. Later on, though, we can kind of look at some basic scribbles, and this, again, was defined and these ideas developed and researched by Rhoda Kellogg. And she defined sort of different kinds of scribbles that are what she considered the building blocks of art. We have vertical lines, horizontal lines, diagonal lines, circles, things that curve, things that are wavy and zigzaggy, and things that are dots. Now, we can see that kids develop through 4 stages of making scribbles. The first is placement. So 2-year-olds are going to scribble at various places on a page. By age 3, we're going to move on to shape, where we're starting to draw basic shapes like circles, squares, triangles, things like that. As soon as we can draw shapes, we begin to combine them into different kinds of things, and this is called the design stage, different kinds of pictures. And then between 4 and 5, we reach the pictorial stage, where we're actually able to draw objects that are recognizable by other people. Whenever we talk about motor skills, we always have a discussion about handedness. Now, don't get handedness confused with, the whole idea that contralateral control, where the left hemisphere controls the right side of the body and the right hemisphere controls the left side of the body. It's not quite that simple. Handedness isn't clearly understood just yet. This is kind of what we know. By 4 months, infants seem to have a clear preference for right hand. Some show no infant preference, but by 4 months, usually right hand. By the 6 to 14 months, though, we start to show a preference. Now, it could be one hand or the other, but we tend to start beginning that preference. And by childhood, we have a clear preference of whether we're going to be right-handed or left-handed. So by the age of 2, it's pretty clear which hand we prefer. So we kind of start out as right hand, and then we kind of go back and forth until about the age of 2, where the preference is clear. Now, we're not exactly sure where handedness comes from, but it does appear to have a genetic component. If both your parents are right-handed, your chance of being right-handed is about 92%. If both of your parents are left-handed, your chances of being left-handed are about 50%. We also know that about 10% of the population does seem to have a preference for left-handedness. And this is something that even can show up prenatally. About 10% of all fetuses, and fetuses suck their thumb, and about 10% of those fetuses that suck their thumbs suck the left thumb as opposed to the right. Now, this is not in your book, but some interesting things that relationships between left-handedness and some other aspects. We often see left-handedness more prominently in folks who have dyslexia, who stutter, who have high blood pressure, who are epileptic, who suffer from schizophrenia, and who suffer from depression. Now, that's not to say one causes the other, but we tend to see higher rates of these things in left-handed folks than in right-handed folks. Certainly, they exist in right-handed folks. Some of the pros of handedness. We also see that folks that are left-handed sometimes tend to have higher levels of math ability, are more successful athletes. Sometimes more seem to have a higher relation to talent in musical field, architecture, and the arts.